So I had a few people email me asking me about how to graph exponential functions, specifically on my math lab. So I wanted to talk about kind of how we do it on paper and then the things to look out for on my math lab. So in general, when we're talking about an exponential function and dealing with the graph, we have this generic function y is equal to a to the x, and we can do a couple of points. So often we plug in 0 and also 1, but those aren't the only ones we have to plug in. And when we do, a to the 0, no matter what your base, will be 1. A to the first power is going to be a, whatever your base is. And so as we plot points, we get this sort of swooping, increasing function that has a horizontal asymptote at y equal to 0. So then if we change the base, something like y is equal to 2 to the x to a specific number, we see those same values popping out for us. Still this swooping, increasing function with this horizontal asymptote at y equal to 0. At 0, it has this output value of 1. At 1, it has this output value of 2. When we're graphing these in my math lab, it gives us the option of selecting kind of a little graphing optic that looks like this. And then when we go to graph that and we want to start selecting points, it's going to come up with a sort of window of options for us. And if there's no change in the function, all we'll have to do is enter down here in this little box what our base is supposed to be. So it's not going to be a base of e. In this situation, it would be a base of 2. But then there will also be transformations that are going to occur, and so we're going to have to sort of plug into this pop-up window what those transformations are. And so even though we may have been graphing using points when we graphed by hand, my math lab just doesn't have that capability or doesn't want us to graph that way, so it's asking us to use a description of the transformations that are occurring along with changing the base to give it the information it needs to create the graph we want in our homework assignments, for example, or on our tests, for example. So if we had something like y is equal to 2 to the x plus 3, where this plus 3 is happening outside of this exponential portion of the function 2 to the x, then this is what we call a vertical shift. And what it is doing is shifting up our graph, our basic graph, up here of 2 to the x, up by 3 units, which means our graph is no longer going to have a horizontal asymptote at y equal to 0. It's now going to have a horizontal asymptote at y equal to 3, which means it's never going to dip below that value of 3. And everything that happened here originally is going to occur over here, only 3 units higher up, which we would also see if we were plotting points. So instead of having an intercept at 0, 1, we're going to have an intercept at 0, 4. Instead of having a point at 1, 2, like we did up here in our basic graph, we're going to have a point at 1, 5. Again, on paper we would do this, but from my math lab, we would have to again select that little option of the sort of swoopy exponential function icon. This window would pop up. We would have to tell it that our base was now 2, and then one of the options says something like vertical shift, so we would have to select vertical shift and a positive 3 because it was a vertical shift up by 3 units because of this plus 3. If we had another sort of transformation of that basic 2 to the x graph, something like 2 to the x plus 3, where that plus 3 or addition of 3 is happening to the input to the x. So this is a different kind of shift. This creates a horizontal shift. That horizontal shift in this case sort of acts counter to what we think. Adding 3 does not actually shift it over to the right 3. It actually shifts our graph to the left 3 units because now all of our input values have to be 3 units smaller to get back to what they were originally on the overall original input function. So if we were graphing this using my math lab, again, we'd need that little icon for the exponential function. That pop-up window would pop up when we try to plot points, and then we would have to tell it we've got a base of 2. We want a horizontal shift this time of 3 units to the left. If we were going to plot points, well, we could plot in some values and see what happens. If I plug in -3, 2 to the -3 plus 3 is the same thing as -3 plus 3 is 0, 2 to the 0, which gives me 1, which is why this point that in our original function was at 0, 1 has now moved to the left 3 units to -3, 1. Our original point that we tracked in our original non-transformed 2 to the x was at 1, 2. Well, that point now doesn't occur until negative 2, 2, because it has to, again, shift everything left 3 units. The other two types of transformations we can have, if we have something like y is equal to negative 2 to the x, that negative 2 is happening on the outside of that exponential function 2 to the x. This causes a reflection across the x-axis, which means we expect it to flip over the x-axis. It's no longer going to be an increasing function, it's going to be a decreasing function. All of the values I saw in my original 2 to the x function are going to be spit out in the y value as their exact opposites. So instead of having a point at 0, 1, like my basic 2 to the x function has, I have a point at 0, negative 1 for this transform function. Instead of having a point at 1, 2, like I expect to have in my original 2 to the x function, I have a point at 1, negative 2. And again, if we're doing this on paper, we can use points and sort of what we know about the basic shape of the graph to get this graph. If we're in my math lab, we still, again, need to use that information in that pop-up window where we're selecting that exponential function graphic. That new pop-up window is plotting up when we try to plot points. We're changing our base, and then there is an option for a reflection across the x-axis, or a reflection across the y-axis. The last sort of individual sort of transformation we can have is y is equal to 2 to the negative x. This action up here to the input causes a reflection across the y-axis, which means this is going to again become a decreasing function. This is just going to reflect it across the y-axis is what it's going to do, so it just sort of spins it around that y-axis for us. So again, our points are shifting around on us. This intercept point is still going to be here at 0, 1, but instead of the point we had in our original function at 1, 2, it's now going to be at negative 1, 2, and so it's going to be showing this sort of decrease. And again, on paper, we'd have these points, we could use them to plot. On my math lab, we just don't have that ability. We have to use the same graphing tool, and then here in this little pop-up window for the points, we would have to tell it that we want to do a reflection across the y-axis. So these are our 4 basic types of transformations, but we can also mix and match those transformations. And again, it's just a matter of us tracking that and then telling my math lab what we want it to do. So for example, still sticking with this base of 2, if we had something like y is equal to, let's say, negative 2 to the x plus 4, well, 2 things are happening to our basic function of y equals 2 to the x. One thing that is occurring is that we have reflected it across the y-axis. Sorry, x-axis, because all of our y's are going to be their opposite values now. Apologize for my misspeaking. And then also we're going to see, because of this plus 4 out here, that we should have this vertical shift up 4 units. And so we would have to indicate those 2 things to my math lab when we're asking it to graph for us. If we were going to be putting in values, we could do that as well if we were trying to plot it by hand. If we plugged in a value like 0, we'd get negative 2 to the 0 plus 4, which is going to be negative 1 plus 4, which will be 3 for us. And then if we had something like 1, negative 2 to the first power plus 4, negative 2 plus 4 gives us 2. So at 0, we have the value of 3. At 1, we have the value of 2. Remember, this graph here, this 2 to the x, originally looks something like this. We have flipped it upside down, and we have asked it to go up, and so now it's going to look something like this. I hope that helps. Thank you for sending in this question. Please keep sending in questions so that I can answer them, and let me know if you need any further explanation.